right, so 17. We have this this gas in a cylinder with this piston that can move. They tell us that the area of the piston is 0.15 meters squared. That's all metric. It's in meters. That's good. The pressure of the gas is maintained at 6,000 pascals. That sounds like a lot. Is that a lot? How much pressure are you feeling right now just from the atmosphere? 101,000. So 6,000 pascals. 6,000 pascals is very little. Okay, as the piston moves inward 20 centimeters, which is 0.2 meters. So is there a change in volume of the gas? Yeah. The gas changes volume. The change of volume is that shaded area. So the change of volume, we take the area of the piston and multiply by the 0.2 meters, how far the piston moved. So the change in the volume comes out, so change in volume, we're going to go 0.15 meters squared times 0.2 meters, and that is 0.03 cubic meters, okay? Now, first question, calculate the work done by the gas. What the heck, man? By the gas? Hey, what does by the gas imply? That the piston's going up. Now look, I'm pretty sure the textbook always says by the gas, no matter regardless of which way the piston's going. If the piston goes down, what does the textbook call that? By the gas. If the piston goes up, what do they call that? By the gas. Have you guys noticed that? By the gas. Look, in the textbook, if you read the textbook, the equation that they give is work equals negative P delta V. That's because the textbook uses the old sign convention. There's an old sign convention for this for work done on a gas or by a gas, and then there's a new sign convention. So just long story short, use the sign convention that I taught you, which is real easy. What's the sign convention I taught you? If the piston goes down, that's considered to be what? Positive work. If the piston goes up, that's negative work. Okay? So all you do for number one, so the pressure is constant. They tell us right here. That's important. Where does it say it? The pressure of the gas, it's maintained at 6,000. It doesn't change. If the pressure did change, then you'd have to do some extra work, right? Because then you'd have a situation like this. You know, pressure, volume. If the pressure was changing, let's see. If the pressure were, let's say you started here and ended there. If you had something like that where the pressure changed, then what would you have to do? Take the area under this, right? But here, it's very straightforward because the pressure is constant. The pressure is constant. It's just like this. All you got to do is take the area under that, P delta V. All right, so the change in volume is 0.03 cubic meters. So this gives us work equal to positive 180. Hey, does the textbook say negative 180? Yeah. Okay, if you read the textbook sign convention for work, if the piston goes down, they call that negative work. They switched the sign convention about 5 years ago or something, and then the textbook is like, we've had this book for like 9 years or something. So answer is positive 180. Like that's what you'd want to do on the AP exam. Okay, second question. If the internal energy of the gas decreases by 8, so the change of internal energy is negative 8 joules. Find the amount of heat removed from the system by heat during the compression. All right, so change of internal energy. What are the two ways to change internal energy? Heat or work. Okay, so here's our equation. They're telling us that this is negative 8. We know that the work is positive 180, right? So what must the heat be? Negative 188, right? The work is positive 180. The change of internal energy was -8, so the heat must be -188.